Should be good. All right. Yeah, it looks good. Okay, let's go here. Okay. Hi. So this is not going to be too long today. Just going to do sort of try and complete a little bit of what we started. So we moved on from MPEG transport stream and we've gone on to RTP. Now RTP is actually, used in the IP world for pretty much what MPEG transport stream is used for. That's the sort of low latency sync timestamp information to transport, sort of like raw audio and video data. What we did last time was, if I go to my code here and go here, we've defined a packet, and a packet has a header, which is something, like 8 to 12 bytes. And then we've just said, the payload is just some slice of bytes. We don't know how long or whatever, it doesn't really matter. That can contain all sorts of stuff. That can contain MPEG transport stream. It can contain motion JPEG. It can contain HEVC, like H.265 video. Commonly, nowadays, it contains Opus audio. So that's audio encoded with the Opus codec. So we see RTP used in, like on WebRTC, which is used for like Slack and, like Google Meet calling. It's used in Apple's FaceTime. It's also used in regular like 4G phone calls, actually use RTP. So yeah, it should be interesting. We were just going into a little bit of a sidetrack here about how it's actually done in 4G is, if we look at a example packet. So here's here's the first packet of Big Buck Bunny over from its MPEG transport stream. So we start with, of course, like the IP, and RTP is almost always done over UDP, if not always. And then we've got our RTP packet. And that takes up something like, we've got 12 bytes here. And then within the RTP packet, we've got our MPEG transport stream, which we can sort of recognize by, for example, seeing this ASCII capital G character here, which is that sync byte that's at the beginning of every single MPEG transport stream packet. Yeah, so let's, so we've got, oh look, there's FFmpeg. So what we'll do is, let's just work on, well, my plan is to take our packet, and in particular the header. Right now we can unmarshal from bytes into a packet, but we want the other way around as well. So we want to be able to marshal from a RTP header and a packet and marshal that into some bytes that we can send off over the network. Yeah, so I mean, that's pretty much it. It shouldn't be too bad because, RTP is actually quite small. It's used in conjunction with a bunch of other protocols and data to actually like coordinate the streaming. So like with SIP, Session Initiation Protocol, and you can even use XMPP, old Jabber protocol. That's actually how FaceTime works, is it actually uses like Jabber to signal stuff and then sets up RTP streams. It's crazy. All right. Yeah, I'm just going to be super boring and just let's do like here. Okay, so we've got the marshalling down. Unmarshalling, let's just do a marshal. So we're going to be going from the packet into a slice of bytes, and we're probably going to get an error at some point. All right. We want a little diagram. Let's get the RFC up. Put that up here. Okay, yeah. All right, so yeah, let's start packing it all in. So we've got a version. Now what we want to check is, we can put a bit of like validation and stuff in here as well. So if the p.version is greater than version RFC 3550, oh yeah, bad version, you know. Probably allocate some bytes soon. We know we want 1, 2, 3, 4, 8, 12. So we know we need at least 12. Almost want to have this as a constant. Whether we export it or not, we probably want to say that, you know, minimum size, something like that. We know that we need to have at least that many, and then we can just have a little bit of documentation to explain it. Let me put that here. Or header size, maybe header size. Okay, so let's start packing this bad boy in. We want in the first byte here, we want to get the version, but then shifted. We've got 2 bits, so we need to shift it along 6. Right. Don't know if I need these here. We've got here the padding bit. Okay, so if p.padding, then 1, 2, 1, 2, 3, 4. Okay, so we toggle that bit. That's just a single bit, and then we've got the extension bit. So if we'll check if that's nil or not nil. Then we need to set that bit. Like that. next 4 bits are from the p.header equals contrib source. Okay, so this is going to come from the length of our contribution source. So how many uint32s we have. Okay, so it's going to be a, can we just use a straight int? Anyway, let's truncate it anyway. Oh no, actually, you know what? We need to do a validation, right? If the length is greater than a 4-bit integer, then we're stuffed. So let's do that. And I've just realized that this isn't P, this is header. Dot. Okay, if the length of the p.header dot contrib source is greater than a 4-bit integer, yeah, I think that's right. 1, 2, 3, 4. Or maybe that. So we got length of p.header.contrib source in the max is max contrib count. So we can just keep going. And we can just, the length is going to be, oh, we can do this. So the contrib count is uint8 of, no. So we can just do it. We'll do the conversion here. Run. Okay. Five, 6, 7. Okay, cool. All right, next one. If the marker bit is set, then we toggle the first bit. 1, 2, 3. 1, 2, 3, 4. Hi, what editor is that? This is the Acme editor. I've got a bit of info about it on the Twitch TV. How do I find my own page? Oh, just there. Oh yeah, there we go. So, oh, I guess you're already there. Yeah, it was about. I thought I remembered that. There we go. Yeah. Hi, Meta Forte. There's a. If you go there, and then there's a link to a very good YouTube video by someone who just does a walkthrough of Acme, all the way from like very basic, you know, like clicking around, all the way through to like full-on workflow demonstration stuff. No worries. Okay, so we've done that. Next up, we want to get our payload type. Okay. This is going to be our payload. We're going to get that, and we want to shift it along 7 positions, right? 1, 2, 3, 4, 5, 6, 7. Yeah. Because we want it in, or we want it starting there. I suppose we could check if it's bigger than. Yeah, we should probably, although it's unlikely. Nah. I don't know whether to. Nah, fuck it, we'll just do that, that's fine. Okay, cool. Marshall buff 1. And the type fills up the next 7 bits. Okay, easy. All right. That's that byte done. So now we'll go on to buff 2. And onwards. So next is just, why does this look, oh, because it's decimal. So 8, so 1, 2, 3, 4, 5, 6, 7, 8. Yeah, great. Okay, so now we just basically do that straight. So we're gonna put that into the 2 to 4. So that's bytes at index 2 and 3. And then which ones? We are getting the uint16 sequence. I think we can just do the same for the rest of them. Oh, sorry, timestamp is 32-bit. Oh yeah, there we go. Okay, cool. So 4 to 4, 5, 6, 7, 8. Sync source is also 32-bit. Oh, right, okay, yeah. All right, well, header. Yeah, okay. Whoops, it's 32. 8 to 12. I love these nice byte aligned values. Beautiful, absolutely beautiful. Sync source. now, what are we going to do now? The next, done that, sync source. So this we're checking if 1, 2, 3. Yeah, okay, so let's see this. Yeah, because I don't know what the hell that means, so that's good. Okay, fine. The extension. Looks like we just need to append all of this stuff, which is pretty easy. Oh no, we need to put the length in there as well. Okay, let's look at the extension in the spec because I can't remember what it exactly looks like. Timestamp. List. With the format described in section. Okay, here we go. Right, okay, so we've got the profile as 2 bytes, then a length of 16-bit. Okay, that's easy. So first up, we're going to get the profile like that, and then we're going to append the length of the slice of bytes. No. We're going to go binary.big endian put, no, append. So, okay, buff equals that append a uint16. And the uint16 we're going to append is, oh no, we're going to append it to buff from so the length of the data, but then that needs to be put into a uint16 as well, so we could probably do that. Maybe length is it, I feel like I should check the length here because yeah, otherwise we're just going to be losing, like we're truncating stuff. Maybe it's okay to truncate and not, I don't know. I feel like that's a tricky one. Sometimes this is one of those things, like we can sort of safely truncate in the sense that like it doesn't affect us as the developer of the package because, you know, who cares? It's not our data. But yeah, when we're actually, yeah, I feel like people should know that they're losing data. I wonder if other parts of the standard library handle this differently. I'm pretty sure they always error. Well, I mean, they at least report how many bytes were read, for example. Like say you, yeah, so yeah, it always tells you. I don't think it ever does it silently. For example, IO reader and IO writer all give you they report the number of bytes read or written. Other things have like max token sizes and stuff like that, and they'll always error. Yeah. Okay. Let's check. Why do I need that header extension? Hey. I guess just because it's part of the spec. Yeah. Say, for example, if there was a packet and we were decoding a packet and the packets and it has the extension sort of field set, then if we didn't account for that, then we would try and decode something and we'd kind of get garbage data because we'd have like, yeah. So I guess that's kind of the reason why, yeah. It sucks because they're even saying like, you know, it's not really meant to be used and all this sort of thing, but there it is in the spec, right? Bit of a pain, hey? Yeah. And the max is OX 1, 2, 3, 4. Okay, you in 16 overlay of that, blah, blah, blah. Okay, it's a bit verbose, but whatever. Cool. Okay, and then afterwards we just append all of the bytes of the data field. So we just, no, not that one. Where is it? Extension. Yeah, okay, so we just append everything after that. Okay, there we go. And then at the check now, yep, and at the end of our packet, we just need to put in all of them. So I'll just check 0 to 15 items, 32 bits each. Maybe this isn't a that isn't a 4-bit integer. Oh yeah, it is. Yeah, right. Right. OXOF. Yeah. Yeah. Okay. Let's. Just do contrib source. So contrib source. You can just do source. Okay, now we just append. Oh no, we need to append it big endian. yeah, I think that's it. Append the uint32. Just reading the spec here, just to make sure there's inserted by mixers. Yeah, okay, that seems fine. Now it needs to actually, it says 15. Oh, it's the greater than or equal to, right? Yeah. Oh no, sorry, yeah, no, that, yeah, that's fine. Okay. It's good. Okay, yeah, then I think that's that bit done. Now there was a part where we were timestamp sequence, no. Oh, the payload type, yeah. I want to check the max value there as well. This is 8 bits, so the maximum value is, right? Eight. Yeah. I want to do this as, I want to use a string here, and then, because I don't just want to say payload type 33. It's like, what the hell is that? 33 means, you know, it's MPEG transport stream. So we can at least use a nice string method on there. So p.header.payload type p.header.payload type greater than max x7. Yeah. There we go. p.header.version. Oh yeah, just the type. Okay, cool. And it's not a payload type, it's a... Oh yeah, no, that'll do. Oh, they call it that, yeah, okay. Well, I guess I can do the whole thing there. Right, but as byte value argument to append. Oh, okay, that, and then that. type, get a payload type. Oh yeah, it's freaking out about that bit. I know I want a string on that though. Okay, let me just quickly do that because it takes 2 seconds. So this is going to be type func t. Or MP. Yeah, I'm not sure what they... I think there'll be like a sort of a standard like way to represent like a standard string sort of thing there, because what is MP2T? Like what does that really mean? And just quickly check. Oh, I want to save that. Just put that over here. Formats, that's it. So if we look, I mean, that's the name, I guess. Yeah, so say if we go to, yeah, say we go to the Opus one. There we go, dynamic or profile name. See, it's just lowercase Opus. It's like, well, why is it lowercase? I just want to know. Payload type. Okay. Then if I look at the one that is, I know is uppercase, which is the MPEG transport stream, which is somewhere here. RFC 2250. This is the stuff that we'll do next, by the way, where we this is like the first few bytes of every RTP payload where the MPEG transport stream is being transported. And the cool thing now is that because we've written a package that, hold on, let me just put this, let me put the light on, it's fucking dark. Okay, and let's have a look here. Temporal reference, active bit, picture header, sequence header, beginning of size, end of size, picture type. Yeah. Audio specific header. I guess I was just curious whether we elementary stream. Anyway, sorry, getting sidetracked. All right, so let's just get the name of the, maybe I can look for MP2T. Doesn't even exist, all right. Payload type. C4 for payload type assignments, okay. This is the old version, but okay, whatever. Payload types. Oh yeah, there we go. Okay, yeah, right. So there's our, yeah. So some are, yeah, okay. So look, we'll use it there. There. And then if we don't know, so we'll just do return unknown. And then, yeah, great. And then it compiles because now it knows that we can use the string, like it knows that we can turn this value into a string. Sweet. All right. Let's, well, I mean, yeah. That's cool. So what we'll do is, yeah, well, let's just leave it like that for a bit. I'm gonna go, I just need to get the laundry off the line. So, and I need to refill my tea because it's empty and it's cold. So I'll just quick tea breaks. I'll get my little, tea break people, hold up. Okay, that'll do. Yeah, that's good. Okay. See you in a sec. 5 minutes. Okay. Where am I? Here. All right. Hey. Okay. So yeah, I'm pretty happy with that. Hey there. Good evening. So now what we really need to do is have some tests, right? I mean, like, or at least we need to test it. So let's give that a go. Oh, actually, I want to do a. Anyway, yeah, sorry. Now, how are we going to test it? Let's have a think. Let me just put this. As I said, yeah, how are we going to test this thing? We could stream from. Let me just think. What we want is, I mean, yeah, okay, let me just sort of sketch this out. So what I'm thinking is, let's do this because I don't know my sketching set up. What we could basically do is get a, this could be Big Buck Bunny. And we could get that from, let's pull this Big Buck Bunny actually. Some other component. Okay, so we got from Big Buck Bunny there, another one. Write that out to our software. So this is just ours, so us. So this could be done RTP. So we'll read it, decode it, then we could encode it again. Let's do it like that. So we're gonna, this is just normal, this is just the file system. Okay, yeah, I got an idea. Okay, let's do it like this. Go. This is gonna be unmarshal. And then we're going to unmarshal. We're going to marshal it again. Here it is. Here it is. Here it is. We got it. We got it. Okay, so this is going to be a. This is a checksum, so let's just do sum. And then we're going to have another one. So when we marshal it again, or rather, hold up. We need to do Yeah, no, the sum isn't going to be that. It's going to be here. So we're going to first, we're going to sum it here. Then we're going to unmarshal it. Then we're going to marshal it, unmarshal, then we're going to marshal it again. And then from the marshaled thing, we're going to get another sum. And then we're just going to check if these two are equal. Like that. As our test. So this is right. I think we can do that. As our test. So there is our test, right? We're just going to set up a listener, do a checksum. Because we're sort of, we know that, you know, that it's okay when it comes in. Yeah, and then we just do that. Yeah. Okay. Now we wrote a little program that gets us part of the way there. RTP listen. So what this does is that it listens UDP port 6969 and then unmarshals the packet. So what we could actually do is grab our checksum here. So we're going to read from, and yeah, okay, so we're going to do sum, can't remember how, okay, easy, all right, so this is some data, okay, so M. Okay, unmarshal it, so now we've got a packet. And then let's marshal back out again. Marshal from our packet. What do we got here? Packet. Okay, if we got an error then okay, just freak out. So our out sum is md5.sum of b. Then we can just check if sum not equal osum. We've got a counter, just so then at least we know which packet we're up to. Yeah, let's do that. Okay, so I'm gonna go packet, marshal packet differs from source. Let's just do that just to see what happens. Remarshal. All right. Yeah, okay, so we've written that logic. So let's get FFmpeg to stream to us. Right? So let's just start a little shell here. we want ffmpeg. So we're just going to choose some, well, we can do any file, it doesn't really matter what it is, but we have a well, actually, I guess it doesn't matter, but anyway, yeah, we got MPEG transport stream, test data, that. Let's do that file. So let's start our server. Okay, let's stream it to it. The format that we want to write out is RTP MPEG-TS. We want to write it to RTP. We're going to write it just to ourselves. Port 6969. Is that all we need? Okay, cool. Now the issue. No, we got a problem, I think. Oh yeah, of course. Now, yeah, we need to do it real time. So we need to say to FFmpeg, hey, like, only read from the source in sort of real time, so that it doesn't just write as like power through as many packets as possible. And then I'm hoping we get a. What? Let me start in a shell, because I don't know what. I'm expecting a different kind of output here. Oh, maybe it doesn't. Oh, there we go. Bad. Oh, nice. Yeah, sorry. Okay. Yeah, no, okay, cool. Yeah, no, this is actually working. Okay, great. Well, there we go. There's an error. That's all right. Let's try again. So, bad version 128. Yeah, shit. Don't even need that. Just need that. Okay, so it doesn't get very far. Bad version. Maybe I'm not storing the version. I'm not. Wait. Maybe. There we go. See, I'm storing it just as. Yeah. Okay. Yeah. All right. So I'm storing it in like the bit field, but what I really want to do is. Like, yeah. Yeah, you know what? I think. One, 0. Yeah, okay, I got it. I think I'm going to store it as a bit field because it's only 2 bits. So this thing where I'm shifting and all that is incorrect. So what I'm want to do is this constant it's not going to be uint8. It's actually going to be, sorry, it's going to be uint8. It's not going to start from 0. It's going to start from, actually, yeah, sorry, no, it will start from 0. And then we'll go, the next one is going to be 0, 1, 1, 2, 3, 4, 5, 6, right? And then the next one is going to be 1, 0. So it's going to be seven plus iota, so it's going to be that. Shifted, you know, I don't know, let's go. Maybe just like that is fine. Something like that. Not really happy with that, but because really it's just 1, 2. I don't know. This is actually 1 shifted to the 6 positions. This is 1 shifted 7. There we go. And then we can have here is still 0. So this is maybe that. Just no iota. I could do 6 plus iota. Like that. As you untyped int constant. Oh, right. So I need to go like that. Or not. Okay, let's try again. Nice. Okay, there we go. Now we can change the so in this case now we just do that because we've stored it as like just as is. Let's go again. Okay. Nice to know how it differs, but yeah. Yeah. It's just the first packet. type is just going to be that mask. That looks okay to me. I can actually just do that. I don't need the double. Yep. Okay, Marshall. One, two, three, four. Cool, there's our string. 1943. Now let's have a look in Wireshark. Packet 1. Okay, the sequence is 147. Whoa, okay, there we go. There's our first problem. Version is that. Padding. Marker. False. Type. 33. Sequence. There, okay, let's study that sequence again. Just check the timestamp as well, 28. .586. Timestamp is also different. Okay. So we're not even, looks like we're not even reading it correctly in the first place. So let's look at that. Okay, unmarshal. Type is there. Okay, sequence. Sync source 149. Whoa. The sequence, see, like, maybe, okay, let's run it again and see if there's not some weird, like, buffering thing happening with, what's the sequence we get? 292, ah, yeah, okay, shit. So, yeah. So what's happening is that we're not getting the order correct. So, yeah. Okay, what we could do is actually write it all. how to do it. We could reorder and then write that to a file, and then yeah. So what's happening is that this thing's just blasting off packets, but what we're getting isn't in the order that, yeah, we're just not getting them back in order. So Go is reading from here, like rather it's reading from the packet connection here, and then it's writing it, but then the packet that we're checking isn't the same as the one that we originally started with. So what we could do is just, for now, maybe try and just do, like, just write out, I mean, yeah, maybe just like that, and then let it run all the way through and just see like if it throws up any other errors. So let's go. Oh, whoops, yeah, my bad, it's printing every packet, hold up. Let's not do that. I'm gonna print the sequence number, but anyway. So it's still running. Oh, and then it's like it finished. Okay. What the fuck? Print F. Right. 917 packets. Yeah, that should be all right. Okay, well, it doesn't error out. I mean, that's, so we know we're getting, like, we're not decoding, like, we're not unmarshalling sort of bad values. Because if we were, then we'd get errors when we're trying to remarshal it again. Yeah. One other fun test might be to actually write this stuff out to another connection, and then like just play the video and see what happens. So we could have something like here where we open an RTP stream and we say, oh, we want to read from port, you know, like, you know, 70 or whatever. RTP. Then, yeah, that might be interesting, because the player on the other end will like work out the reordering and stuff like that, because we'll get, you know, it'll get the RTP sequence number, timestamps, and then blah blah blah. Let's try that maybe. So let's modify our program to what's the packet economy? I need to open another one. What gives me back a packet con? might do the trick. Let's see what that UDP conjugate gets me. What's the listen pack dial filecon? It's an UDP. Oh, that's just a IO writer. That actually might be interesting. Because then we can just hook up a pipe and just pipe it between them. That might be the best thing. Yeah, let's do that. So let's change, instead of listen packet, we'll do listen UDP. I suppose this is all available for the local system except multicast. Yeah. Okay, cool. I suppose what IP address is all addresses except multicast with the port field available. Is there port numbers are randomly chosen? Yeah, okay. So we'll do this. So listen UDP. Nah, that's fine. We'll do that. Okay, and then we'll go. Yeah. Read. Okay, let's do so we'll call it VLC. So that's who we're speaking to. Dial UDP. And we said port 7070. Okay. Oh, let's draw now. Oh, tell us about the dirt bike. Oh, yeah, you want to hear about that? I can, but maybe maybe after this is done. Is that okay? Yeah, it's funny. Nobody asked about that yet. Is that the profile picture? That must be it, right? Otherwise, where else would it come from? Sorry, stupid question. Okay, so we want to set up a pipe correct single member user connect code expecting IO reader with a, or we can do an IO copy. No, wait, how does this work again? We just want to... Or maybe we can just do it like this and then just have that, and then we've got our bytes that we've read, and then we can just go VLC. VLC.write B. just do that. That might actually work. Oh, no. One. Oh, the... Oh, I needed to... Oh, of course, like the local... where I'm coming from, right? Because otherwise I won't know where to send stuff back to. Yeah. Oh, local address. Ugh. Dial. Yeah. Okay. Can I do... Listen UDP, what does that give me? UDP connection. Oh, and this is incorrect as well. I need the local address. Yeah, okay, let me, yeah, okay, UDP address. Type UDP address. Do that. We can do UDP here. Let's do that. Nice and easy. Yep. Cool. Okay, ready? Let's see. Let's see. So in theory, oh yeah, that's okay. So that's okay. So VLC is waiting. Nah, VLC is not having it. Open RTP unicast. Yeah, so is that dial 7070? Oh, shit. Bad error. Connection. Great. Okay. All right. Okay. So now we were good. And then if I do that, then it should, yeah. Come on, work for me. Damn. Maybe. So now, just to make sure I've got it right. So now if I do that and then send it, yeah, good. Okay, do that. Oh my God, I'm not even writing the payload. overriding the fucking payload, right? Like, I'm not... Would that help? Do I need to write the payload? Okay. Like that. Because we've... Yeah, okay. Ready? Whoa. Who hears that? What the fuck? That was fun. So no errors writing the packet. I mean, like sending bytes to the... Yeah. Out of curiosity. Still going. Oh, what am I doing? What am I doing? What am I doing? I'm just writing out the packets like as fast as I can. So that's no good. I need to do it like in... It needs to be timed correctly. I'm sort of hoping that it's okay by just like trying to write them out as quickly as I get them, but that doesn't... Yeah, no, that's no good. There's that, plus also I'm getting some kind of, you know, issues here. So what might be interesting is, let's print out the packet again. Let's die there. And then let's try again. Do that. Okay, and then we'll... Yeah, so sequence 3574. Yeah, see, like, what? Like, so 3574, if we... So if we read the RTP and the sequence, okay, let's just go down. Oh no, there. So the sequence is going to increase. So let's see if there is actually a 3574. Nope. What if I... Unless what I'm looking at here isn't actually... What I'm looking at in Wireshark isn't what I should be looking at. way to do it is, yeah, okay. So that's, now we're going to capture all the packets. Okay, it's done. Done there. 917. Oh yeah, that was, that's better. That's actually the number we wanted. Okay, so let's open that up with Wireshark. Cool. Sequence starts with 299. Fucking hell. Ends with 1215. Okay, well, there we go. So that's cool. Let's, what am I thinking? I mean, oh no, the sequence starts arbitrarily, doesn't it? I think the sequence number doesn't, I don't think it's meant to start at 0. It's actually, yeah, I think that's the case. So if we just knock this stuff out, RTP, RFC, and the initial value should be random. There we go. Okay. All right, so there's that. Certainly for yeah, we still do want to get the same packet out as we do in. Let's try, see if we can see anything like very obviously wrong here. Like if we print out the packet and then let's not do VLC anymore. Let's just get rid of that altogether because we're just not ready. And then we're going to so that's 80, yep. 21. Okay, so straight up there we got an error. So the two, we're not reading the type. It seems we're not reading the type correctly. Zero, and then the sequence is next. Okay, so sequence, well, we don't know that. That's just whatever. But we definitely should be getting the same. We definitely should be getting 2, 1 at that byte. So let's see what we're doing. So the, okay, flags, marker. Yeah. So marker 80. That's that byte. So we're getting like the markers toggled somehow. Okay. So let's try header.type. All right, so let's see how we're reading that in. Oh, this isn't shifted 7. This is the type is a. Okay. It's just that, just simple. Even not even just because the header type. This is a 7-bit integer. So I didn't shift it 7. What's that about? I can just do like that. Just that. Button palette. Oh, okay, so I can just do that. Whoa, there we go. Look at that. Whoa, okay. So that's, at least so far, we haven't hit. That means the packets are identical. Because the program's still running. That means that, yeah. It's just spending a lot of time printing. Okay, looking good. Not what I expected, but okay. Are you getting any errors? Oh, done. Okay, fuck. That's cool. Should we try and write to VLC again? Are we feeling lucky? I mean, maybe, yeah, because again, like how we read it in, well, anyway, let's just see what happens. So we're going to go UDP. Yeah, okay, if we've got checksum error, then just bail out. And then finally we can go right to VLC. And if that just again, just die there as well. Okay, let's do that. Let's open VLC. Read RTP unicast port 7070. 7070. Okay, that's reading. And then let's go. Ooh, ooh, ooh. Yeah, there we go. Woo. Oh. Oh. Oh, yeah, that's right. Yeah, because it's only like 4 seconds worth of video or something. Yeah. That's so cool. Yeah, nice. And because it's RTP, it doesn't know like where it's up to or anything. It's just like just reading it as it gets it. Cool. Wow, I'm okay. I'll mark a bit. Whoops. Guess we can get rid of that. Shall we try again just to feel fucking very clever? Okay, we're reading. Cool. This is messages. Did that finish earlier than last time? So now we can just keep sending it. Yeah. So the server can keep running. It's just going to keep pumping it out. It doesn't care. Brilliant. Fucking let's send it again. So really FFmpeg is doing a bunch of hard, like, you know, it's going, okay, it's generating the sequence, timestamps, blah, 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 all this sort of shit. Genius. Well, fuck. No, it seems all right. Seems all right. Okay, so let's. I mean, how could we? A nice, like, sort of reproducible, clear test. I can't think of anything yet. What I may refer to is, I might need to read through the standard library and just see ways that they test this sort of thing, because, like, certainly what we could do is just set up a like in a normal Go test, just set up a little UDP listener listening on a random port, and then sending stuff to it, and then receiving it again, and then maybe just hoping that and then I just don't know how to generate a useful RTP payload. Now, here's the thing. There's actually a bit in the spec, and maybe this is for next time because this would be kind of ridiculous, but there's actually a... we say it's for sending RTPs, for sending audio and video data, right? But there's actually part of the spec a way to send text over RTP. So maybe that's a good little... Here we go. That's it. RTP payload format for text conversation. Brilliant. So maybe we can do that. That way we don't have to have like weird sort of like opaque data in our repository. Now we've already got like the transport stream data, but I don't know. I feel like this is... Yeah, I'll have to have a think about it. Text T140 format? Is this going into like the rationale? Go on, tell us why you'd do it. T.140 data is... What is this? Only one block of T.140 data refers to T140 block. Is this like kind of a non-UTF-8? Oh, it's UTF-8 encoded. Okay. Most of them are single ISO 10646 character. There are multiple characters. Each character UTF-8 encoded into one or more octets. Because this is something that we could like very easily, we can specify this in code in a way that, and send that over UDP, receive it over UDP, and check that we got the same message back again. And we can actually do like, we can decode the payload and say, hey, like, is this the same thing? I think that's easier than doing... Well, it's a good little test. It doesn't have to be the only test. No way, but yeah, that's actually... Maybe we can do that. I don't know how I thought of that. I read that like a couple of times and I was like, text, why would you use that? Okay, now I can kind of see a reason. Mr. Hellstrom has come up with something there. And yeah. Okay. All right, well, I think I'm happy to commit this just as is for now. Then add tests afterwards. And documentation and blah, blah, blah. I'll check there's no debug. Okay, cool. I don't know if fun packages even in here. Oh yeah, will be fun. Yeah, okay. Very cool. We won't save that server just because... RFC 4103. have a look at our test diagram because this is going to be easier. Let's get that and let's do this. Okay, so we send it to the loopback interface. Okay, I'm writing that really as a reminder to myself because, yeah. Cool. Oh, that was 60-ish lines of code. Let's go. All right. I think that is, for now, that is it for this evening because it's Sunday night, and I'm going to put this. So that was only very short, a mere 2 hours 30 minutes, but a productive one. So yeah, thanks everybody. That was good fun. If yeah, as always, write in. No account needed. If you ever want to see anything in particular, if you think, oh, for any reason, write in. It's fine. Yeah, I think next time we'll try and next thing we'll get those text payloads over RTP, just so we just have some kind of testing that's more than just well, nothing right now, basically manual testing, which kind of sucks. And yeah, no, that's cool. And then after that, maybe we'll try and actually be able to encode MPEG transport stream in RTP ourselves. Now, I'm not super keen on doing MPEG transport stream because I'm a bit fed up of it. But maybe we could do Opus audio because that would be, you know, that would be cool. That's relevant. That's used. Audio is just so much easier than video for a whole bunch of reasons. And it's sort of fun to test, right? Because you can just like, you know, I could do it from like my laptop and like speak into the microphone and maybe somebody else can listen on the other end, like a walkie-talkie. Yeah, that might be cool. So yeah, as always, thanks for tuning in and saying hey. Oh, sorry, I forgot. Okay, I will talk about the dirt bike. I'll just I'll hop off YouTube just because I like to keep them a little bit shorter. And yeah, I'll say good night, good morning, or good afternoon wherever you are in the world. And see you next time. Won't be long. All right. Cheers. Bye. Hello. Oh yeah. Okay. Yeah. Okay. Bye. All right.